Welcome back. In Unit 5, we'll talk about sensation and perception. 5.1, which is this video, we'll talk about sensation. How is sensation different from perception? The colloquial expressions, we use sensation and perception interchangeably. We say have these sensations. When you say that, you're talking about perception because you're referring to conscious experience. And conscious experience is not a part of sensation. Conscious experience is a part of perception. Sensation is the capture of information by your sense organs. Perception, on the other hand, happens at the level of the brain. It is interpretation of the captured information. If sense organs are capturing external information, perception is the brain interpreting the information at the conscious level. Also keep in mind, not everything that is captured by your sense organs is interpreted. Only a part of what is captured is perceived or interpreted. As we discussed in the big picture, what helps us going from a lot of information to little information is attention. The outcomes for this video, which is visual sensation, are listed here. We are only talking about visual sensation because this is an important area that is searched, but also because visual sensation is key in solving the puzzle. You need to be able to capture the printed information. Can you close your eyes and read what's on the screen? No, you didn't. You need your eyes to capture the printed letters, interpret it. So that's why we pay attention to the visual sensation. In this unit, we'll talk about structures involved, the process of visual sensation, about how our eyes capture light. Visual sensation include eyes and brain. This is, if you see, this is more like a small part or a socket filled with fluid. This particular socket is covered by lens. The light passes through the lens because of refraction, and image of whatever you're looking at will fall on your inner layer of your eyeball. The lens is covered by the circular muscle, like the shutter of your camera. This muscle can constrict or dilate, changing the size of the opening as a result of the movement of this circular muscle. The circular muscle itself is called the iris, and the opening that is left by the circular muscle is called pupil. When there is more light, iris will constrict, reducing opening, and less amount of light passes through the pupil. If there is less light, then your iris retracts, creating a larger opening. Now, coming to this is a protective layer of cornea, transparent layer. Light first passes through the cornea, passes through the pupil, then lens and image is formed on this innermost layer of the eye, the retina. There is fovea. This is the part where there are more photoreceptors. In the center of the eye, the retina has 3 layers of cells. First layer is here, the second layer is here, and this is the third layer of cells. The first layer of cells is comprised of photoreceptors, specialized neurons that are sensitive to light. When light falls on the photoreceptors, they convert light into neural impulses. This process itself is sensation. There are 2 kinds of photoreceptors, rods and cones. Rods are for dim light vision. In other words, they help us identify the object as opposed to give more details about the color. Cone, on the other hand, are for color vision. They give more detailed information about the object. In fact, there are more rods than there are cones. Again, rods for dim light vision and cones for color vision or daylight vision. The second layer of cells is the bipolar layer cells. Bipolar layer cells are connections between photoreceptors and the next layer of cells, the ganglion cells, Ganglion ganglion cells. When light enters through the pupil, the lens, it goes through the ganglion cell layer, bipolar cell layer, and reaches photoreceptors. Because the bipolar layers and the ganglion cell layer are not sensitive to light, nothing happens there. Once the light reaches photoreceptors, create neural impulses, the action potential. These action potential generated here in photoreceptors will be transferred from photoreceptors to the bipolar cells, from bipolar cells to the ganglion cells. The axons of the ganglionic cells come out of each eyeball as a bundle of axons forming the optic nerve. The axons of the ganglion 10 layers go through a specific part of the eyeball, where there are no photoreceptors, called blind spot or optic disc. This is a part where there are no photoreceptors. The information that is captured by each eye goes to thalamus. From thalamus, information then is sent to the occipital lobe, which is a visual perception center. There's a visual cortex in the occipital lobe. That's where the information is sent to. And information from both the eyes goes through this. The fibers are these are optic nerve fibers coming from each eye, right? And they crisscross in a way that they form a structure here called optic chiasm, if you remember from last um, video. So they form a structure called optic chiasm, right? And this also should remind you about how the system follows contralaterality, but not at the level of the eye, but at the level of the visual field. In other words, the information in the left visual field is sent to the right occipital cortex, and information in the right visual field is sent to the opposite occipital cortex. So contralaterality in vision is at the level of the visual field. Now, let's understand the process of visual sensation. In other words, how once the information is captured by the retina, what happens to this information. Then we'll talk about how eyes capture information. If you remember, retina has three layers of cells: the rods and cones, the bipolar cells, and the ganglion cell layer. The information captured by rods and cones here is transferred to bipolar cells and then to ganglionic cells. From there, it goes out through the optic nerve fibers. An important point to notice here is, first of all, there are more rods, as you can see here, than cones. Even in this single layer, at this specific point, right, there are more rods than cones. And throughout the retinal layer of the eye, you'll see more of rods and less of cones. In fact, there are 120 million rods in each eye and only 7 million cones. In total, there are 127 million photoreceptors. So 127 million photoreceptors capture they capture the information from the outside. But the issue here is there are only 1 million ganglionic cells. As you can see, the number decreases as you go from photoreceptors to bipolar cells to ganglionic cell layer. So just think of these photoreceptors as pixels in your camera. These retinal cells, rods and cones, are capturing, this is just an analogy, 127 million pixels of information. But then once the information is sent to the ganglionic cell layer, has a lesser resolution in the sense that there are only 1 million cells. 127 million pixels of information should be converted into 1 million pixels of information. In other words, information must be compressed somehow. In fact, information captured by your photoreceptors is compressed so that it can fit the fewer ganglionic cells, and this process is called compression. The capture of information by your photoreceptors is sensation. The information is sent to the brain so it can perceive, interpret the information. But before the information is sent to the brain, right, it is compressed right here at the level of the eye. You can think of it compression as a summarization. Information is compressed in a way that the most important information is definitely and sent to the brain. The important information include the edges, the contours, the shades, information sufficient for you to detect what an object is, because that's what perception is, which is interpreting what the captured information is. Identification. If you think about it, we said the retinal cells, in fact, the photoreceptors capture light. That is sensation. Then we talk about what happens to this captured information. Information goes to the brain. Now, we'll talk about how information is captured by your retinal cells. The next outcome, how eyes capture information. Keep in mind, we are talking about what happens before compression. It's how eyes capture information from the external world. Try to look around. Try to see an action. Maybe look at your friends. Now, think about it. Experiencing this event that's happening in front of you continuously, right? It doesn't feel like there is a gap. It's a continuous process without any gaps and delays. Here's the question. How do our eyes capture this information? Is it captured like a video where everything is captured continuously, or is it captured intermittently? Pause here and think. Is it a continuous capture of information, or is it it's intermittent capture of information. If you said intermittent capture, you're absolutely right. Our eyes don't capture light or information continuously. In fact, your eyes your eyes go through a quick jerky moment of saccade. Call your friend or your family member sitting next to you and ask them to stay somewhere and try to see their eyes. Even when they're not reading, their eyes will make jerky movements called saccades. During saccade, your eyes can't capture information. It's only between saccades, between moments, when it captures information. That is called fixation. If you're, say, reading a sentence after a long day at work, Mr. Blah 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 enjoyed. What happens is your eyes fixate on the words. Fixation is when your eyes capture information. Then your eyes move from one word to another, and this moment is saccade. So there's a fixation and a saccade, and your eyes capture information during fixations. You go through fixation saccade cycles. Fixation saccade cycles roughly last for around 250 milliseconds. Of these 250 milliseconds, 200 milliseconds are spent on fixation and 50 milliseconds are spent on saccade. In other words, you go through 200 milliseconds of fixation, your eyes don't move. Then for 50 milliseconds, they move. Again, for 200 milliseconds, they don't move. And for 50 milliseconds, they move. And each SF cycle lasts, let's say, 250 milliseconds. Right? 200 milliseconds of fixation and 50 milliseconds of saccade. And think about it. In a second, how many SF cycles do you think your eyes go through? That's right. Around 4, right? 3 to 4. 250 milliseconds. 250 milliseconds. So how many 250 milliseconds you find in 1 second? 1000 milliseconds will make 1 second. In 1 second, your eyes will have roughly 3 to 4 SF cycles, 3 saccades and 3 fixations. The box here represents a fixation. The box here represents a fixation. And the length of this box represents the time of one fixation for 200 milliseconds. There is another fixation for 200 milliseconds. And between fixations, your eyes move. I represented this as this empty place, saccade. You go from one word to another word. So a total of 250 milliseconds. Only during fixation does your eyes capture information from the external world. During saccade, it is blind to the external information. Now, this is what I want you to do. Pause the video here, then find a mirror and try to see if you can see your own saccade. What do I mean by that? Well, look at your eyes in the mirror and look away and come back and try to look at your eyes again. Try to see if you can capture your eye movements while you're looking away and looking back at your eyes. The question is, can you see your saccades? I'm going to pause and ask you to actually see if you can find a mirror. Don't use the camera phone. What did you see? Can you see your saccade? You're absolutely right. You cannot see your saccade because during a saccade, your eyes don't capture any information. It's completely blind to the external world. There is no way you can see the saccade. But if you use from your phone, it's likely you may see your eyes moving. The reason for that is not because you can see your saccades, it's because of the buffer of the image of your moving eyes captured by the camera. This blindness during a saccade is called inattentional blindness. Now here is another interesting thing. We said fixation lasts for 200 milliseconds, followed by a saccade, which lasts for 50 milliseconds, and the process continues. That's why it's just the fixation saccade cycle. Now, here's an interesting thing. We said that you can't see your own saccade because your eyes are blind at that point. So we said your eyes only capture information during fixation, which is for 200 milliseconds. But here's another interesting thing. Your eyes don't capture information for the entire 200 milliseconds. They only capture information during the initial 50 milliseconds. And for the remaining 150 milliseconds of the fixation, your eyes are blind again. What? Yes. If take one fixation and saccade cycle, which is 250 milliseconds. Out of 250 milliseconds, 50 milliseconds, you're blind. Plus for 150 more milliseconds, you're again blind, which is like 200 milliseconds. The only time your eyes capture any information is during the initial 50 milliseconds of the 200 milliseconds. If you take one cycle, which has 250 milliseconds, You're only capturing information during 50 milliseconds, and for the remaining 200 milliseconds, you are blind. So, in one SF cycle, for how long is the system blind? 80% of the time. For 200 milliseconds of 250 milliseconds, you're blind. That's scary, right? So your eyes are blind most of the times, 75 to 80. Again, it depends on the length of the fixation, which is not exactly 200. That's roughly 70 to 80%. So 70 to 80% of the time you are blind, and for the remaining 20 to 30% of the time, the only time your eyes are capturing anything. It is scary, right? And you can generalize that for the entire day with your eyes open. Here's an interesting question. If you take one SF cycle, and if you're only capturing information during the initial 50 milliseconds of the fixation, what happens during this 200 milliseconds when our eyes are blind? In other words, during the 150 milliseconds of fixation plus the 50 milliseconds of saccade. What do you think is happening? Why don't we feel the gaps? The reason why we don't feel the gap is whatever is captured during the initial 50 milliseconds, that is being perceived by the brain for the remaining 200 milliseconds. Does it make sense? So your eyes are capturing information during 50 milliseconds. For 200 milliseconds, your brain is perceiving, interpreting, making sense of what is being captured. So your brain is busy processing the captured information. It will capture information again, and the brain is busy perceiving the captured information. That's why you don't feel that delay. You don't feel that gap. So what happens when the eyes are blind? Well, you don't realize they are blind because your brain is kicking in and it is perceiving what is being captured. So sensation is mere capture of information by your eyes, intermittently capturing information during fixations and only during the 50 milliseconds of the fixation. For the remaining time, you are perceiving. Now the next question is, what is perception? How does your brain perceive the captured information? I hope you liked it. Have fun learning. Thank you.